Behind all this stuff we use every single day, the food in our kitchens, the cars we get around in, there's this whole world of incredible industrial power. We're talking about forces like heat and pressure on a scale that's honestly hard to wrap your head around. And when the systems built to control all that power fail, well, the results can be an absolute nightmare.
This quote from the source material for today's explainer is, well, it's a chillingly perfect metaphor, isn't it? It perfectly describes how the machinery that basically runs modern life can flip in an instant and become deadly for the people operating it. It's a stark reminder that contained energy is always looking for a way out.
So that's the big question, right? How does this happen? It's almost never one single big explosion. It's usually a cascade, a chain reaction of small mistakes, maybe a misunderstanding of some basic physics, or a safety rule that got ignored. To figure this out, we're going to look at two really tragic case studies where the unbending laws of physics collided head-on with human error.
All right, our first case takes us to a food processing plant. Now, that might not be a place you'd think of as extremely dangerous, but as you're about to see, the physics involved in cooking on an industrial scale are unbelievably powerful and totally unforgiving.
The details of what happened here are they're horrific. A 62-year-old employee, Jose Milena, went inside a 35-foot-long industrial oven to do some maintenance. But somehow, tragically, he was still in there when his coworker sealed the door, and the 2-hour cooking cycle for 12,000 pounds of tuna started.
So you have to ask, how in the world could this happen? Well, it unfolded in this heartbreaking series of missteps. One worker goes in to do his job. Another worker, tragically, thinks he saw him go to the restroom, and so he seals the giant door shut. And then the cycle begins. This was a complete and total failure of what's called lockout/tagout procedures, a safety system designed for this exact scenario. Just a catastrophic breakdown in communication.
And at the very heart of this tragedy is a really fundamental principle of physics. See, we're not just talking about it being hot. We're talking about immense, incredible pressure. To cook that much tuna, steam gets pumped into that sealed oven, raising the temperature to 270 degrees Fahrenheit. But here's the kicker. That steam expands to 1,700 times the volume of the water it came from. That creates an enormous, crushing force. It is, quite literally, a massive pressure cooker.
Okay, let's shift to our second case. This one involves a totally different kind of energy, but one that is every bit as lethal. We're now at a Caterpillar foundry in Illinois, a place where raw metal is literally melted down and transformed by unimaginable heat.
2,000 degrees Fahrenheit. Just let that number sink in. That was the temperature of the molten iron inside a giant pot at the foundry. It's a temperature that's honestly difficult for our minds to even process. It's the heat of creation, sure, but it's also the heat of instant destruction. And tragically, a worker named Stephen Dierkes fell into one of these pots. Just to put that number into some perspective for you, the heat that worker was exposed to is nearly the same temperature as actual volcanic lava. This is an environment where survival isn't measured in minutes or even seconds. It's measured in fractions of a second.
The physics here are brutally simple. It's all about thermal energy. At 2,000 degrees, solid metal turns to liquid, and any organic matter is just annihilated, almost instantly. This tragedy highlights the absolute non-negotiable need for safety containment. Things like guardrails, harnesses, fail-safes, anything to keep people separated from a hazard of this magnitude.
So we've got these two incredibly different incidents, right? One involves pressure and steam. The other involves extreme, mind-boggling heat. But what's the common thread? What connects them? Let's kind of zoom out and look at the anatomy of these failures together.
And here it is. This is the core issue. In both of these cases, a powerful physical force, either pressurized steam or extreme thermal energy, was the weapon, so to speak. But the root cause, that was the human factor. At Bumblebee, it was a total breakdown of procedures, of oversight. At Caterpillar, it was a failure of the physical safety barriers. In both of these tragic situations, the immense power of the physics involved was fatally underestimated. The systems and the people running them just got complacent to the very forces they were supposed to be controlling.
The point of all this is that these tragedies offer these stark, unforgettable lessons. First, you can never, ever underestimate stored energy, whether it's from steam or molten metal. It's this invisible power that can turn lethal in an instant. Second, safety protocols aren't suggestions. They need backups for the backups, and they have to be reinforced constantly. And finally, human oversight, checking your work, checking your coworkers' work, communicating. That's not optional. It is the single most important safety system there is. Understanding the physics isn't just for the engineers. It's fundamental to staying alive.
And that leaves us with one last, really crucial thought. We are surrounded by systems that harness these incredible physical forces all day, every day. The pressure in the water pipes under our streets, the electricity humming inside our walls, the jet engines on the planes flying overhead. These awful events are a powerful, powerful reminder that vigilance and safety, they're the only thing standing between a normal day and a mechanical nightmare.